Okay, question 1. Find the following limits. So let's do part A. It's a limit of x squared plus 4x minus 12 over x squared minus 2x. And x is approaching 2. Okay, so if you just sub x is equal to 2 into this equation, you can see the bottom is going to be 0 and the top is also 0. Okay, in this case, usually there is a common factor between the top and the bottom. Here, the bottom is x times x minus 2. The top is x plus 6 times x minus 2. Okay, then these two parts cancel out. So it's a limit x plus 2 over x plus 6 over x. Okay, so it's 8 over 2. The result is 4. So what's similar to part A is, for example, part E. Limit x cubed minus 1 over x squared minus 1. X is approaching 1. So when x is approaching 1, as you can see, if you do the substitution, it's 1 cubed minus 1 over 1 squared minus 1. Right? So it's going to be 0 over 0. It doesn't make any sense. So what you can do, right, you can rewrite the bottom as x minus 1 times x plus 1. And the top as x minus 1 times x squared plus x plus 1. Right, so these two parts cancel out. It's a limit x squared plus x plus 1 over x plus 1. So now you can do the substitution. Right, now if you do the substitution, it's just 1 squared plus 1 over 1 plus 1. The result is 3 over 2. Right. And part F is very similar. Limit x squared minus 9 over 2x squared plus 7x plus 3. And x is approaching negative 3. Right, here, when x is negative 3, the top is 0. The bottom is, you plug in, it's also 0. Okay, so you can't write it down. Instead, you can write the top as x plus 3, x minus 3. And the bottom is 2x plus 1 times x plus 3. So here, both the top and the bottom, they cancel out. Right, the top and the bottom, they cancel out. So it's a limit x minus 3 over 2x plus 1. Here the top is negative 6, the bottom is negative 5. It is 6 over 5. Okay, part G. Limit x is approaching 1 over x minus 1 over x minus 1. Okay, now, when x is 1, right, the bottom is 0, the top is 0. So here, what's the common factor? Here, the top is just 1 over x minus 1. Okay, the bottom, you can write it as 1 over x minus 1 times negative x. Okay, because negative x times negative 1 is 1. So negative x times negative 1 is x, and negative x times 1 over x, it is negative 1. So It's two parts. It can be cancelled out. It's a limit. X is approaching 1, negative 1 over x. The result is negative 1. Okay? Then part H. Okay, part H, you can just do the substitution. Part H, you can just do the substitution because now, if you do the substitution, right, cosine 2x, which is cosine pi over cosine half pi. Cosine half pi is 0 minus sine half pi. Okay, sine half pi is 1. So cosine pi is negative 1 over 0 minus 1. So the result is 1. Okay? So here, whenever do the substitution, it's 0 over 0, then usually there's a common factor. Okay. Then let's do problem C and problem D. So in this case, now x is approaching infinity. So when x is approaching infinity, everything's changed because now when x is approaching infinity, okay, the top is going to be approaching infinity, and the bottom is also approaching infinity. Okay, so both sides are approaching infinity, so what will the result be? Okay, in this case, what we usually do is we divide both sides by x to the highest power. Here, the top highest power is x squared, the bottom highest power is x squared. So we divide both sides by x squared. Okay, then when x is approaching infinity, this part is 0, 0, 0. So the result is 7 over 2. Okay. Part D. Part D is very similar. But the difference is now x is approaching negative infinity. The top is x over the bottom is square root of x squared plus 5x plus 1. Okay, so now we divide both sides. Now the top, the highest power is just x. Right, the bottom is just this whole thing. Okay, what's the highest power? Right, it looks like it's x squared, but it's actually not because you have to square root the x squared. So that result is just x. So you just divide both sides by x. You just need to divide both sides by x. Right. And here's the tricky part. You obviously want to simplify the bottom part, but we move over x into the square root. Okay, so here's a simple case. For example, negative 3, right? Is it equal to square root of negative 3 squared? Right? Are they the same? No, because if you move negative number into a square root, you have to put a negative sign in front. Okay, so it's negative square root of negative 3 squared. So here is the same. It should be negative because x is approaching negative infinity. So x is a negative number. So when you move it inside, it is x squared over x squared plus 5x over x squared plus 1 over x squared. Okay, so it's a limit x is approaching negative infinity, 1 over square root of -1 plus 5 over x plus 1 over x squared. So the result is -1. Okay, so the result is -1. Last question is question B. Okay, why question B to the last? Because question B, we need to use a squeeze theorem. When x is approaching 0, x to the power 4 cosine cube 1 over x squared. Okay, why do you need to use a squeeze theorem? Because here, when x is approaching 0, yes, this part is approaching 0. But this part, you can see 1 over x squared, it's approaching infinity. So cosine something approaching infinity, because cosine is a periodic function. So you don't have a certain result. So that's why we need to use a squeeze theorem. To use a squeeze theorem, first we need to find that out whether this function is between two functions or not. So this function, because cosine any angle is smaller or equal to 1, greater or equal to -1. So this is between -1 and 1. So it times x to the power 4. It is smaller or equal to x to the power 4. It's greater or equal to -x to the power 4. Okay? That's the first part of the squeeze theorem. Second part of the squeeze theorem is that for both sides, their limit, right? For both sides, their limits are the same when x is approaching 0. So limit -x to the power 4, the result is 0. And for the right-hand side, it's limit x to the power 4, the result is also 0. Okay, for both sides, the limits are both 0. Then you can make a conclusion by squeeze theorem. Okay, the limit of the function in between is also, okay, the limit of this function in between is also the same value. This limit is also 0. Okay, same as the left-hand side and the right-hand side.